So welcome to the next section on Level 3 Mechanics, circular motion. And before we even begin circular motion, we need to define some terms. Okay, so starting up, if you walked around the circle once, what would be your total distance? Okay, so the circumference essentially is 2 pi r, so 2 pi meters, or 6.28 roughly meters. Okay, now we can define circular distance in terms of this generic radius, and how many radiuses or radii are there in one full revolution? Well, there would be 2 pi rad, or radii. Rad, we just kind of contract it to rad. Okay, and that's the term we use a lot in circular motion. Rather than saying revolutions in degrees, we use the term radian or rad. Okay, so in terms of the timing of circular motion, we use the term period, which has the symbol of capital T and the units of seconds. And it's basically a period is the time for one complete revolution of an object undergoing circular motion. And you would have already looked at earlier in year 9, year 10, the idea of linear motion, that velocity equals distance over time. We have a corresponding equation when we're talking about circular motion, and that's known as angular velocity, which has the symbol omega, that kind of W-looking symbol. And it's the angular distance divided by time. And we've already looked at what the angular distance is in the previous slides. That's going to be the time for one revolution, which is, time, but the distance of one revolution, which is 2 pi, and it's going to be divided by that time for one revolution. And the units for angular velocity are radians per second, rad seconds to the -1. So in terms of linear velocity, at any given point, an object with circular motion will also have a associated instantaneous linear velocity. And this velocity essentially will be a tangent to that object's motion around the circle, a tangent to that curve, or to the curve. Okay, so in terms of calculating linear velocity, so you'd have velocity equals distance over time if it was just a straight line. Obviously, we're going around a circle. So the velocity will be 2 pi r, which is the distance of one complete rotation, which you can work out as being this, basically this, well, it is the circumference, and the time for one complete rotation, the capital T, the period. Okay, so in terms of calculating linear velocity, so you got velocity equals now 2 pi r over capital T, and omega, the angular velocity, equals 2 pi over t. So therefore, velocity will equal omega times the radius. Okay, that's going to be the linear velocity of that object undergoing circular motion. Okay, so at a tangent to that circle. So remembering back from your earlier life as a year 9, year 10, year 11 student, there are 3 ways an object can experience acceleration. There's speeding up, all good. There's slowing down, but also finally there is changing direction. Okay, that's the 3rd way that an object can accelerate. So in terms of circular motion, we have the concept of centripetal acceleration. Okay, so it's basically how fast there's a change of velocity in respect to the direction of the object. Okay, so centripetal acceleration, which has that subscript c on the a, equals v squared, the velocity squared, times the radius from the center of rotation. Okay, so in terms of centripetal acceleration, this is where vectors come in. Okay, so basically it's the change between velocity vectors. Okay, so you've got the u, okay, which is going to be at tangents, and also the linear velocity, which we've already experienced and calculated, and is going to be, the acceleration is always going to be pointing towards the center of an object for that very reason. Okay, it's basically the changing of the direction of the velocity, not the magnitude. Magnitude will stay the same, but the direction will change, and that's going to be the sum of that change in direction as the object moves around, and the acceleration is always going to be pointing towards the center. Okay, so a centripetal acceleration equals v squared over r. Okay, velocity equals 2 pi r over t. Velocity equals omega r. Therefore, through rearrangement, the acceleration will be 2 pi r over t all squared, because you're just substituting the second equation into the first equation. Open the brackets up, so you get 4 pi squared r squared over t squared divided by r, and that will give another equation to calculate the tangential velocity, 4 pi squared r divided by that time period squared. Okay, another equation. So in terms of forces as well, because centripetal force, we know that Newton's second law says that when you have an acceleration, and we're witnessing that with that change of direction, there must be a force causing that change of velocity, that change of direction. So we know from Newton's second law, force equals mass times acceleration. We also have the acceleration of centripetal acceleration of v squared divided by r. So if we basically rearrange the equation, substitute in, the centripetal force will equal mv squared divided by the radius r. Okay, so that's what we're just doing there. Okay. And you can also, in terms of calculating the tangential velocity, as force equals mv squared divided by r, and velocity equals 2 pi r over capital T, and more importantly, v equals omega r, which we learned about earlier, then the force will equal the mass times omega r squared, just substituting v equals omega r into the equation, divided by r, which will give you the final equation, m omega squared r, as giving the tangential velocity also. So just to summarize there, then you've got the different equations of circular motion. So velocity equals omega r, omega of course being the angular velocity. Acceleration equals both v squared divided by r and also 4 pi squared r divided by the time period all squared. And then force equals mv squared divided by r, which can then be, through substitution, transformed to incorporate angular velocity of m omega squared r. So velocities in meters per second, angular velocity, angular momentum is later. Angular velocity is going to be radians per second. Centripetal acceleration is going to be in meters per second as well. That's just going to be the centripetal acceleration. And the centripetal force is again derived from force equals mass times acceleration, Newton's second law. And the important points are at the start. So we've got a new way of looking at velocity in circles, which is angular velocity, which is going to be 2 pi over the time period. And in terms of linear speed, velocity equals 2 pi r over the time period, which also equals the angular velocity times the radius.